Now, the first law of thermodynamics is, we've already talked about it. It's conservation of energy. That means that whatever energy is inside of a system is conserved. And the only way that the energy inside of a system changes is if there is work introduced or heat. Now, I don't remember if we've talked about heat yet, but I want to talk about it really briefly just to make sure. When we talk about the word heat, we're talking about the transfer of energy from one form to another, from one object to another. Sorry, not one form. So if I have two objects that are separated by a distance, and now imagine that this object is hotter than this object, and it's irradiating heat through convection, a form of transfer of energy. This object is able to deliver thermal energy from here to here. So the process of that amount of thermal energy, the amount of thermal energy that's transferring from this hotter object to this object is referred to the amount of heat. So when we use the word heat, we're talking about the transfer of thermal energy or other kind of energy typically from one form to another. So when you hear the word heat, that's exactly what we're talking about. Okay? So the first law of thermodynamics says that energy inside of a system is conserved. So the total energy is conserved. Now, if it's experiencing a change in energy, then we can say that work is being done on the object or heat is being transferred to the object. So what we like to say is that the total energy, the total final energy minus the total initial energy. So that's basically saying the change in energy is any kind of change in energy is either due to work or due to heat. Now, when we talk about this, we can say that we got this. The change in internal energy that is associated with that object, it's internal energy, it's thermal energy. Oh, not work. Has that relationship. Okay? So that means that the change in its energy is caused by heat, which we express with the Q. I don't know exactly why. I'm sure it's probably because it's a Greek root somewhere. Minus the work done. Now, why is it minus work? Well, if you think about it, if it's the work done by that pocket of gas, if you will, inside of a cylinder, if that's the work done by that gas, that energy is being removed from the gas and delivered to that piston or whatever that it's moving. So that energy is removed from the system. Now, if there's work being done on the gas, like the piston compressing it, then that's negative work. It reduces the volume of it. The force and the displacement are in the opposite direction. So that turns out to be negative work, meaning that you have a positive change in work there. So it's negative because it's talking about the gas itself. Is the gas doing work, or is work being done on it? If it's doing work, which that equation is expressing, then it's going to be removing energy from the system to somewhere else. If work is being done, then it's adding energy into the system. Okay? And then you just simply got heat, that value of Q. Okay, so that's the first law of thermodynamics. Energy is conserved. So if energy does change in a system, so this meaning the change in the energy of the system, that heat is being introduced to the system or taken away in some cases, and work is being done on the system. Okay? So that's the first law of thermodynamics.